Hello again, this is Ms. Fallon. This time I'm returning to the geometry midterm review packet that I gave, and I thought it would be good to go over the trigonometry section. This is Unit 6, right triangles. I know a lot of people had a lot of questions on this unit, so I wanted to go through these problems. This will probably be the last video that I can make before I go home before snow days. Anyway, so let's start. Number 1. Make sure before you start anything that has to do with trigonometry that your calculator is in degrees mode. Let's see if I can remember how to pull up the calculator here. Okay, while that's pulling up, let's make sure it didn't go over. It is loading on my other screen. So let's bring that over here, and there it is. Okay, so let's run down how to do the mode. Okay, look, it's already in degree mode, but let's say we didn't see that and we were on the home screen and it looks something like this when we turned it on. So you are going to be on your home screen, and if you have the TI-84 Plus, you can see at the very top where it says degrees. But if you are not using this calculator, you don't. And to see which mode you're in, you are going to hit the mode button. And if you are in radian mode, it's going to look like this when you first come to the mode screen. Radians is going to be highlighted. To change it, use your arrow buttons to come over to degree, and you tap enter down at the very bottom, and it'll move the highlight over to the word degree, and then you'll be all ready to go. Okay, so it's good to have my calculator up in the background. I can second quit, or second mode, because quit is right above mode, and that returns me to my home screen. So my calculator is all ready. It's in degree mode. I can return to this. Okay, so number 1, the 12-foot bed of a dump truck loaded with heavy stone must rise to an angle of 36 degrees before the stone will spill out. Approximately how high must the front of the bed rise to unload? Wow. Okay, so this whole section is on right triangles. So what I'm doing is looking for a right triangle. This truck is kind of in my way, so I am actually going to come over here and create a similar diagram, a simpler diagram also, of what's going on. Okay, now we're talking. So I created my simpler diagram and I labeled it accordingly. Whenever I see a right triangle with a bizarre angle measure in the corner, like 36 degrees, my first instinct is to think this is trigonometry. So I'm thinking of sine, cosine, tangent, and all of that stuff. And I see that they actually gave you a hint there that we were going to be using that because they provided some approximations for what sine of 36 degrees is, what cosine of 36 degrees is, and what tangent of 36 degrees is. My suspicion is that this problem came from a test where maybe people were only using 4 function calculators that could only add, subtract, multiply, and divide and didn't have sine, cosine, tangent buttons. So they provided a decimal approximation for each of these just in case you didn't have that on your calculator. Otherwise, we're just going to rely on our calculator and see what happens. We're not even going to use these approximations. So my first step is that I circle the angle that I have been given. Second step is I label the sides. I tend to start with the hypotenuse, which is always opposite the right angle. Then I label the opposite which is opposite the angle we're talking about, and whatever is left over is my adjacent side. The next step is to figure out if we're going to be using sine, cosine, or tangent. So we have to remember our mnemonic device, our memory device, which is so, ka, toa. So I look at what has been given to me and I see that I have an x, which is the opposite, and I have a 12, which is the hypotenuse. So I'm looking for one of my trig ratios, sine, cosine, or tangent, that uses the opposite and the hypotenuse. And so now I know I need the sine function. So now I've determined that I need sine. So I can go ahead and put that down as the first part of my equation. And I'll write it down here. Sine. Sine of what? Sine of the angle measure. And the angle measure given to us is 36 degrees. So that's the first part of my equation. We put the equals. So, and SOHCAHTOA tells us that we need opposite over adjacent. So I go to the side opposite, and that is labeled x. So I put that in the top, and it's over the hypotenuse, and the hypotenuse is labeled 12. Now I solve the equation. To solve the equation, I'll look to see where the variable is. The variable is in the top. If the variable is in the top, that means I multiply. Multiply what? I multiply the sine 36 times the 12, and that's going to give me my value for x. And I tend to write it just like that, where the 12 is out in front. Sine of 36 has to stick together. And now I'm going to go over to my calculator, which I have up in the background. And I am going to put in 12 sine 36, enter. And I get 7.05 something. So I come back over to here. It's x x is approximately 7.05 something. So which of these answer choices, 6 feet, 7 feet, 9 feet, or 10 feet, is closest to 7.05? Well, that would be choice B. Okay, well, let's not stop there. Let's keep going. So I'm going to adjust this a little bit so that I can handle the calculator and some of these problems at the same time. Okay, I think that, let's move my calculator over a little bit. And let's put this like about right here, and that might be good. Okay, I can still scroll. We're all good. Okay, thank you for being patient with that. Let's go on to number 2. Reuben attached a wire between 2 poles on a hill. Okay, well, anyway, I'm looking for the right triangle. And that looks like we've got a 20-degree angle down there, and up there is 80 feet. And they want, which is closest to x? Okay, so once again, I see a 20-degree angle, and one of the sides labeled as a number, and they're asking for the length of another side, and this makes me think of trig. So step 1, circle the angle. Step 2, label the sides. Opposite the right angle is the hypotenuse. Opposite the angle itself is opposite. And the one that's left over is adjacent. Once again, I come through and I try to figure out which pieces I have. I have 80 feet. I'm looking for x. And so now I believe I have adjacent and hypotenuse, which means I'm going to be using ka of SOHCAHTOA. And the C stands for cosine. And cosine is equal to adjacent over hypotenuse. So I do cosine of 20 degrees equals what's labeled as my adjacent is x, and the hypotenuse is 80. Once again, the variable is in the top, so I can multiply. And so I come to my calculator and I do 80 cosine 20. 80 cosine 20. Enter, and I get about 75.1 something. So continued. Which of these answer choices is that closest to? Well, it's closest to choice D, 75 feet. So far, so good. Scrolling back up to the top, we're going to come to number 3. We have a billboard supported by a 20-foot lengths of tubing. Let's see if I can make this just a little bigger. Okay, so once again, we have a right triangle. And what are they looking for? I don't see an X in this diagram. I see my right triangle. So let's see, a billboard is supported by a 20-foot lengths of tubing at an angle of 60 degrees. So this is kind of difficult to see, so I'm going to label this 20 up here and this 60 in here. How far from the base of the billboard is the bottom end of the brace? Ah, I thought they were going to want to know the height of the billboard, but they didn't. They wanted to know how far from the base of the billboard is the bottom end of the brace. It's always good to know what they're looking for. So we follow our directions again. We circle the angle that we've been given. We label our sides, hypotenuse, opposite, adjacent, and it looks like, again, we will be using cosine because we have the adjacent and the hypotenuse. So we have cosine of the angle, which is 60 degrees, is equal to adjacent over hypotenuse. The variable is on the top again. So we can multiply the 20 times cosine of 60. So I don't know where to write this. I'm running out of room. So I need 20 cosine 60. Okay, let's go over to my calculator. 20 cosine 60. Wow, I get 10. Well, that is very exact. And there it is, sitting right there. And that does make sense for the problem. So the answer choice is C. Well, we're doing lots of cosine and lots of variables in the top. I hope we can get some variables in other places so you can see what that looks like. Number 4, a carpenter is building a flight of stairs as pictured in the drawing. And once again, we've got my right triangle. What is the horizontal distance from the foot of the stairs to the wall? The horizontal distance from the foot of the stairs to the wall, foot of the stairs being there, the wall. They want to know what this length is. So I follow my steps. I circle the angle that's been given. I label my sides, hypotenuse. This is the opposite, and this is the adjacent. And once again, we're going to be using cosine. So we have cosine of 30 degrees is equal to adjacent over hypotenuse. So we multiply 20 cosine 30. So let's come over here. We do 20 cosine 30, enter, and we get 17.32. And which one is closest? B. See, I've been circling my answers in red, so let me go back and do that because I like to be consistent. All right, number 5. Okay, we've had 3 cosine problems in a row. Let's hope that number 5 is maybe a little different. We have a right triangle, so that's the same. We have angle Q is 20 degrees, and angle S is 90, which I already marked. I was kind of making an assumption, so thank goodness it didn't get me into trouble. What is the length to the nearest meter of RS? RS is the height there. Okay, so we circle the angle, we label our sides. Ooh, this time we have the opposite, so it's not going to be cosine, it's going to be sine. So we have sine of 20 is equal to opposite over hypotenuse. The variable is in the top, so we multiply these two. So x has got to be 1,000 sine 20. So I can remember my calculator, 1,000 sine 20. 342. About 342. And that is closest to A. Once again, I'm going to circle that in red to be consistent, and we're good to go. So we're moving on to the next page. I believe there's a second page. Yes, there is. Ooh, lots of good stuff going on here. Okay, let's see what's going on. An airplane is 34 ground miles from the end of the runway and 6 miles high when it begins its approach to the airport. To the nearest mile, what is the distance? PA. Oh, they even gave it to us. That's nice. PA, they want to know what this distance is. So they want to know the length of the hypotenuse. And they gave us the other two sides. This is not trig. This is the Pythagorean theorem. So if I set up my Pythagorean theorem formula and then plug in what I know, let's see, A is 6, so we have 6 squared. B is 34, so we have 34 squared. And C is our x, so we have x squared, and now we just simplify. We have 36. I wonder what 34 squared is. Oh, I have a calculator up so I can look. 34 squared, 1156. Let's go to x squared. I add 36 to it. And that's 1192. Take the square root of both sides, and I'll need to know what the square root of 1192 is, right? Yeah, because they're looking for the closest approximation. So let's come over here. I'm going to do second x squared, and that puts down my square root. 1192, enter. And I get 34.525. 34.5 is closest to this one. So once again, in the calculator, that was 34.52. So you can see how I got to the answer choice. Alrighty. Number 7. We have a right triangle with the measures shown. We have 7 inches and 25 inches. Okay, and they want to know the length of BC. Hey, this is Pythagorean theorem again, isn't it? So I can label one leg A, one leg B, and one hypotenuse of C. So I have A squared plus B squared is equal to C squared. A is 7. B is x squared. Ooh, tricky. And C is 25. So we have to simplify this. This is 49. The x squared just sits there because there's nothing we can do. And 25 squared is 625. So I'm going to isolate that x squared, subtract 49 from both sides. Let's see, 576. And then I need to take the square root of both sides. Ooh, I see 576 in the answer choices, and I bet you they want me to choose it. But square root of 576 is not the same as 576 itself. Square root, and I can do it over here, second x squared, 576, enter, turns out to be 24. So they were really hoping somebody was going to choose that 576, but it wasn't going to be us. So scrolling back up to the top, oh, a circle problem, but we haven't studied circles. And let me get rid of some of this stuff up here so we can focus on this problem. What's the diameter of the circle shown? Diameter. Hopefully some of you know that the diameter is the distance across the circle if it goes through the center. Okay, so what I see though is a right triangle. Nice. And I see each of the legs is being 6. And they want to know what this is. Well, once again, this is Pythagorean theorem. Mark each leg and the hypotenuse. Here's the formula. Remember, C is always the hypotenuse. So we have 6 squared plus 6 squared is equal to x squared, is what I called it. I didn't call it C. And we have 36 plus 36 is equal to x squared. That's 72 is equal to x squared. And then that means x is equal to the square root of 72. Oh, man. None of my answer choices match square root of 72. Never fear, I'm going to find out what square root of 72 is on the calculator. It is 8.485. Etc., etc., etc. And all I have to do is figure out which one of these answer choices up here equals the same thing. So we'll start with the 3 square root 2. So I put in my 3. I go to second x squared for my square root, and I go 2, and I hit enter, and that's not it, is it? So now I can come over here and I can cross off A. Come back to the calculator. Let's do 3 second x squared, 3, enter. Closer, but not 8.485 something. So I can come back over here and cross off B. Let's come over here and do 6 second x squared, 2, and boom, there it is, 8.485. So my answer choice is 6 square root 2 inches. Sneaky, tricky, especially if you didn't know what a diameter was. Kites. A drawing of Mark's kite is shown below. What is the length of the short section of the outer frame indicated by the X in the drawing? Well, we have a right triangle here, and we have a 9, and we have a 12. This is Pythagorean theorem again. So I can do a squared plus b squared is equal to c squared. We have 9 squared plus 12 squared is equal to x squared. It's 81 plus 144 is equal to x squared. That's 5, 2, carry the 1, that's 225 is equal to x squared. Does that match any of my answer choices? Not yet, so I'm going to keep going. Square root of 225, and I happen to know, because I have it memorized, 15 squared is 225, so the square root of 225 must be 15, and there it is. Well, that concludes the explanation of the right triangles portion of the review packet. It may be that I wish there were more examples that had trig functions other than sine and cosine, and also other than having just the variable in the top. Make a mental note for next year. But I'll send along the link to the original trig videos.